Alrighty, we are up on YouTube. Welcome everyone who is joining. If you are joining on Zoom, please feel free to throw a hello and where you're from in the chat, if you would like. There we go. Alrighty. We apologize right off the bat for the disaster of communication this morning. I'm sorry about that. We had to, our own success has been our failure, I guess. So we had almost 1,000 people registered for our sessions, but we were only getting about 150 people per. And so we wanted to tighten up our registration to make room for more people. And in so doing, we had to cancel the old Insider's Guide and start a new Insider's Guide event in Zoom. And if you got the cancellation notice, it was because we canceled the old one, not this one. So this one will be the one going forward. You're all here. You've all made it. You don't need to hear all this. Welcome.
Yeah. And Zoom didn't ask us if it was okay if it put a cancel note out.
We'd already had to try to get around the fact that if we had removed your registrations, everyone's registrations, and asked them all to re-register, you would never be allowed to register again. So that's why we had to create the whole new event. And it's I think we've mentioned it before, but we're planning to do some more work with public libraries, and I think we'll see an uptick in the number of registrants. So we really needed to make some space for the newcomers. Mm-hmm.
Great.
So welcome everyone who's here. Great to see you all. And a reminder, if you'd like your comments to be seen by everybody, if you're in Zoom and you'd like to talk to everyone, to change your little blue bar from, it now says host and panelists, to everyone, and you get to talk to everybody. And we're going to be talking about gas giants today. Chris's shirt is appropriate. My shirt is not.
Yes. I had to put on my gas giants shirt. No doubt.
It's a good one. Oh, shall we start off with a poll?
Sure, let's do that.
Okay, so we're going to take a poll. And this poll is I'm going to launch it right now. So get ready to vote on your favorite gas giant. And maybe embarrassing as it is, I had to check with Chris to make sure that Uranus and Neptune, which I spelled Neptube, but I meant Neptune, are indeed gas giants. So, A+ astronomer here.
Well, anyone watching it on RAS Canada, they'll be watching it on Neptube. We're fine.
It's fine. Oh, that'd be a much better name for it.
So I can't vote, but I'll reveal my choice.
What's your choice?
Later on. No, I don't want to bias anybody.
Okay.
Well, it's like kids. It's so hard to choose.
It's true. I'll give you all 5 more seconds to vote. 5, 4, 3, 2, 1. All right, we have a pretty close to a tie, very close to a tie between Jupiter and Saturn. No one really likes Uranus, which is a shame. That might be Phil. If Phil's joining, our executive director, Uranus is his favorite of the planets, of the gas giants. And then Neptune, sorry everyone, got a couple votes.
Very good.
So yours, Chris.
I love looking at Neptune. It's so unique in the telescope. I mean, it's one of those things where, hey, everybody, come look at Neptune. Isn't that cool? And then they go, oh, is that all it is? It's just a little tiny dot, blue dot. But I think it's amazing how far away it is and its intense color. So it's one of my favorite things to look at. But everybody loves Saturn. I mean, yeah, why not?
Saturn is one of those like iconic planets, you know?
Yeah.
It's the one that everyone sees and goes, ooh.
So we're going to spend the next little while talking about the gas giants and make it a gas giant spectacular, because it's the perfect slot and perfect date for that, because we're smack dab between the oppositions of Jupiter and the oppositions of Saturn. So, sometimes we work this out so that it comes out just right. So what I thought I'd do is start out by demoing basically where to see the planets and when, and even going into the next several months. So not just for this week or this month, but for the rest of the year, basically. And I'll even preview a few things that are going to happen next year and in the years to come. Then we'll actually dive a little deeper, and we'll give you some things to look at on each planet, some phenomenon that you can enjoy and appreciate, and then some tips, things like which filters work best for planets and things like that. So that's kind of game plan for this afternoon. So as always, I'm going to use my Stellarium software here. I'm going to bring up my little clock and advance the time into this evening and give everybody, go ahead.
We can't see your screen.
Oh, haven't done that this year yet. Hang on. Here we go.
I can imagine what you're doing.
Screen one, share. Here we go.
There it is. Thank you.
I was out with my telescope on the driveway a few nights ago, and where I live, there are a lot of trees. So it actually takes a while before you could start to see things get high enough to see them. And some passersby walked by, and they were looking up and pointing at the sky. And I said, "What are you looking at?" And they said they were noticing the Big Dipper was above the northeastern horizon. It was getting dark enough to see the stars. And I said, "Oh, you just missed seeing Venus. It had already got too low in the west, but it was in the same kind of area, the same direction." I said, "Come back in an hour or so when you can look at Jupiter and Saturn. They're kind of in the other direction." And they did. So they came back later and they got to see Jupiter and Saturn. And of course, the cool thing about the planets is that, even though they're the things that move in the sky, they don't move that fast, so that once you figure out where they are, you can then check into them again the next day, the next week, even a few weeks hence. You can share your knowledge with your friends and family, impress your neighbors, and all of that kind of thing. So let's figure out where everything is.
And if we're not doing stuff to impress our friends, I don't know why we know astronomy. That's my main motivation.
So last year we had Jupiter and Saturn sort of tucked close to each other. Because Jupiter moves faster in its orbit. Basically, Jupiter jumps a zodiac constellation every year. So about 12 zodiac constellations, and Jupiter's orbit is about 12 years. So it basically jumps by about a zodiac constellation every year. Saturn's orbit is slower. It's a 30-year orbit. So it moves at roughly half the speed or half that rate. And so this year you'll have noticed that Jupiter, whereas last year it was on the other side until the end of the year when they did that close conjunction in December. Now Jupiter is east of Saturn and is rising about an hour after it, and will follow it across the sky all night long. So the story right now is that Saturn is already past opposition. That was in August 2nd. So that means that when a planet is at opposition, the Earth is positioned between the planet and the sun. And that means that those two objects are opposite one another in our sky. So at opposition, as the sun sets, that object is rising. And then it sets in the morning as the sun comes up, and the cycle continues. So Saturn is already a couple of weeks past opposition, and that means that it's actually rising a little bit earlier than sunset. So it's already in the sky, technically, when the sun goes down. And since the sun is setting in the northwest, then that means that Saturn's in the southeast. But if you live in a place like I do with lots of trees and houses, then it takes a while for you to be able to spot it once it climbs high enough. If you live, on the lake or something, you could start looking for it right away once it starts getting dark. So the cool thing is that we're going to be able to enjoy, even though those two planets, Jupiter and Saturn, are about to have their oppositions. We're going to be able to enjoy them for the rest of the year, basically. So right now, as I say, Saturn is already up at sunset, and it won't set until the pre-dawn, just before dawn. It'll set in the southwest, and Jupiter is following it across, and they'll be visible until about late December. And the earlier sunsets that we get in the autumn will help us keep them in sight, keep them from getting swallowed up by the twilight, if you like. I want to point out something cool that you can do in Stellarium. You can actually bring up a setting in here. I'll just go into my F4 markings and add the anti-solar point. So the anti-solar point, or ASP, that's the point in the sky opposite the sun at any given time. So you can see back on August 2nd, Saturn was beside the anti-solar point, so it's opposite the sun in the sky. And now get to where we are now, and the anti-solar point is getting close to Jupiter. So Jupiter reaches its opposition on 19th, 20th, basically Thursday or so of the week. And that's always cool. We'll talk a bit more about opposition impact on viewing the planets here in a second. So yeah, so as I said, Saturn sets just before dawn. Jupiter is going to be setting about an hour later than that. Now, what I wanted to mention here is that what's going to happen at the end of the year. So let me just bring up my bookmarks and clear these bookmarks. And so I preset a few cool events to watch out for in the coming days. Let me just bring these up. So I'm going to put on my glasses so I can see everything properly. All right. So basically, by the time we get to the end of the year, so we're going to look for around December 28th. So as every week ticks by, Jupiter and Saturn will migrate west as the sky, as the Earth's orbit around the sun causes everything in the sky to migrate from the eastern half of the sky to the western half of the sky. And by the time we get to the end of the year, this is December 28th, you're going to see we've got Jupiter and Saturn hanging out with Mercury and Venus, and that'll be a cool planetary grouping to kick off the end of the year. So that's something you want to keep an eye out for. All right, let's go back to tonight. Looking into the future. Now, the other little challenge that we have is because Jupiter and Saturn are reaching opposition in August, the ecliptic is not very high in the summertime months. So the ecliptic is the yellow line here. And you can see that compared to the zenith, so the green Z is the zenith, that's 90 degrees up. So the ecliptic is basically only a third of the way above the southern horizon at nighttime. And that means that planets that are in opposition during the summer months, they don't climb that high in the sky. And of course, that makes their view in a telescope less than perfect. Eventually, because they're all moving eastward every year, they'll eventually migrate and become at opposition during the autumn and then eventually the winter months when they'll be, autumn is great because it's, the weather will still be nice for getting outside with your telescope. And that's only a couple of years away before really Jupiter transitions into its opposition in September. And then I think a few years after that, we'll get Saturn sort of getting nice and high in the sky around the time they're at opposition. All right, so next year, this is this year, next year, let me just bring these up here. Let's bring these back. Oops, a year or so. Next year, you're going to see that they're even wider apart. So they'll continue to separate every year as Jupiter moves east faster. Jupiter is actually going to reach its perihelion point. So just as Earth has an aphelion, perihelion that changes our distance from the sun, each of the planets in the solar system have the same thing happening. And so when Jupiter reaches its perihelion or closest distance or minimum distance from the sun, and when we're at opposition, when it's at opposition with us, we're truly minimizing our distance from the planet. So that means the Jupiter will be largest in its telescopes, largest and brightest in the sky, around 2023. So right now in a telescope, Jupiter's disk shows about 49 arc seconds in diameter. And in 2023, that'll grow to about 50 arc seconds, so a little bit bigger than it is right now. And then it'll start gradually, slowly shrinking in size in the years beyond that. So the next perihelion for Jupiter is in November 29th. Let's see. Yeah, so that's Jupiter. Saturn, it's the same effect. So Saturn also will get larger and small, closer and farther from the Earth, depending on whether it's at its perihelion or aphelion. Saturn's next perihelion won't be until 2032. And so in 2032, the rings, which are currently about 50% or a little bit, 20% or so bigger than Jupiter's disk size. So the rings are right now about 47.6 arc seconds in diameter. They'll get a little bit bigger when Saturn gets to its perihelion. They'll get up to, it's now 43. It'll get up to almost 48. arcseconds
Wow,
across.
that's a much bigger difference than
Yeah, it's about, 15% or something like that. I haven't done the math.
It's still
The
very
other
small.
cool thing, I'm going to just go back to today again. Here we go. The other cool thing is that because Saturn has an axial tilt, a little bit more than the Earth's axial tilt. So our axial tilt is 23.5 degrees. Saturn's is about 26.5 degrees. And that means that at times it's leaning towards the inner solar system, and at times it's leaning away from the inner solar system. And when it's leaning mostly towards the sun or towards the inner solar system, its rings are tipped more downwards, more open to us. And then at times in between those two, then we see the rings edge on. And so over the next few years, we're moving into that orientation where Saturn is going to be approaching its equinox, where it's neither pointed towards nor away from the sun. And at that time, the rings will be viewed edge on from Earth. So if I sit here and I turn off, I'm just going to flip into equatorial and turn off the daylight and the sun, so you can, and the ground. So this is Saturn now. Next year, the year after, the year after, you can see that the rings are getting more and more and more edge on. And the actual date when they're most edge on will be March 22nd of 2025. So I should have that in here. But unfortunately, they'll be practically gone for a short period of time. But unfortunately, it's going to be really close to the sun. So I'll just put a zero horizon so you can see what I mean. So Saturn will be just too close to the sun for that to be really effective for us to see it easily. Here's the morning sky.
Aww.
So unfortunately, from the surface of the Earth, we're not going to be able to see Saturn's rings. But, a space telescope or maybe astronaut somewhere else might be able to see it. That's only a few years away.
Have you observed Saturn when its rings have been
I didn't. I wasn't active in astronomy the last time it happened. So it's about every 15 years that this happens, right? The next one, though, is April 1st, 2039. So where's my April 1st, 2039? Here it is.
That's a good time of year, right?
And this one's in the evening. Look at that.
Hey.
Perfectly dark evening sky.
At 9 p.m. That's 10 p.m. That's reasonable.
Yeah, 10 p.m. Yeah. Yeah.
All right, write it down in your notebooks, everybody. What was it? April 1st. It's not a joke.
Around April 1st. Well, it'll close up over a number of days and then it'll start opening up. So so it'll be a period of time where, depending on the quality of your telescope, if your telescope's not very good, you'll probably lose the rings sooner. If your telescope's more accurate and powerful, then you'll be able to detect them as a fine line for a few more days. But a cool other thing, a few more cool things to bear in mind. So because Jupiter's axial tilt is only 3 degrees, right? It sits up straight in the solar system. And so the moons orbit in its plane. And that's why Jupiter's moons always form in a line. But because Saturn has that tilt, the moons of Saturn are usually distributed all around the planet to either side, above and below. But when the rings are edge on, so are the moon orbits. So see how all the moons of Saturn are lined up?
Yeah, that's very cool.
So that's something we only get every 15 years. And the other thing we get is, and we'll talk a bit more about this in a bit, is that when the rings are edge on like that, you can get the moons of Saturn casting shadows on the planet. So we get Jupiter shadow transit, moon shadow transits. We'll get Saturn moon shadow transits.
2039, everybody write it down.
Yeah.
Oh, that's going to be cool.
All right.
Now's the time to start practicing to get good enough and to acquire good enough telescopes that you can see shadow transits. Because I don't know if I don't think mine's good enough quite yet to see shadow transits. Oh, so get ready now.
What's that? Yeah, 2020, 19 years, 18 years.
Time. I'm sure telescopes will advance in that time.
Yeah, we're good. All right, so let's just talk about observing Saturn. Just some general tips, some general thoughts on it for folks. So Saturn in the sky always looks kind of a yellowish color. Obviously, Mars looks reddish, and Venus looks very bright white. Jupiter tends to be a little creamier than Venus, but white. And Saturn has this distinctive yellowish tint to it. So that's one way you can confirm that you're seeing Saturn when you're seeing the dot in the sky. Right now, Saturn is, and I'll just advance the hour to about 10 o'clock. There's nothing really around it in the way of bright stars at the moment. You've got the constellation of Capricornus, which isn't a very bright one, and Jupiter is also in Aquarius, which isn't a very bright constellation. But you will notice that you've got the teapot of Sagittarius and the Milky Way just about 2 or 3 fifths diameters to the west. So, when you're looking at Saturn, you're going to be probably enjoying the Milky Way and the bright stars of the teapot. And then you've got the summer triangle basically right above the gas giant planets this year. So here's Vega, Deneb, and Altair, and the summer triangle sitting kind of right above them. So that gives you a perspective. So by what I'm driving at really is that it's pretty hard to mistake these planets for anything else because there's really nothing else bright that's near them. So we said August 2nd was Saturn opposition. So at opposition, that brought Saturn to within 1.337 billion kilometers of the Earth, or about 73.4 light minutes delay. So we're seeing it in the past by 74 light minutes, by 74 minutes. It peaked in its apparent magnitude at about 0.18, but there's a phenomenon that makes Saturn just a little bit extra bright when it's at opposition. It's called the Seliger Effect, and it's basically backscattered glint or sunlight from particles in the rings, and it actually sort of makes the brightness curve just peak up a little bit right at opposition for a couple of a day or two. So Seliger Effect. Jupiter doesn't really get it because Jupiter has a gaseous atmosphere, and the ball of Saturn doesn't really contribute because it's also a gas ball. But anything that's a solid surface that can glint sunlight can add it. So Mars gets extra bright at opposition because of that phenomenon. The moon does it every month when it's full. The moon gets bright because it's more fully illuminated, but it's also a bit extra bright because all those crystals on the lunar surface are sending back that extra glint of sunlight. So it's the Seliger Effect. If you want to look at Saturn in your telescope, you want to use about 60 power, 50 or 60 power. If the seeing is good, so if the view through the telescope is very stable and very steady, then by all means go ahead and magnify it more. But if the seeing conditions aren't great, then cranking up the power doesn't really help you much. I mean, there are times when I look at the stripes on Jupiter, for example, and if I try to magnify them too much, I start losing the effect. So it's better just to dial it back. And the tip for viewing the planets and for anything in astronomy is to take your time. So if you've got, people around you that are all taking a look through your telescope, encourage them to take a few moments, like count a few steamboats while they're looking. So really, you're trying to wait for those moments when the air steadies and you get that sharp, extra crisp view for a moment. So, take your time. Let's see. So Saturn by now, a couple of weeks after opposition, it's dropped in brightness a little bit. It's down to magnitude 2.4, and it'll slowly get a little bit dimmer over time, just as we, increase our distance from it a little bit. Let's see. I talked about the ring plane. The other thing to notice right now is that because the rings are closing up, we can start to see the ball of the planet extending beyond the disk of the rings on the top and peeking out from below the rings on the bottom. So last year, that wasn't the case. So if I switch this back to 2020, see how the bottom wasn't really stretching beyond the rings, and that's a function of that ring closing up. So that's something to keep an eye out for.
Have you been able to observe the shadow of the shadow that Saturn casts on its rings?
Yeah. So you can see here that there's a gap here where the rings are are missing. And that's the shadow of the ball of the planet on the rings. Now, bear in mind that when the planet is at opposition, let me just put this back to equatorial and wind this back to the second.
Oh, of course, there wouldn't be a shadow.
So there's barely any shadow visible at opposition because that shadow is heading straight away from us. But the farther you get, so if you look at the planet before opposition, let me just get rid of the ground here. See how the shadow is on this side? And then as you get to opposition, it transitions from basically no planet shadow. And then as we get into later in August and September, then it comes back.
Cool.
Yeah. So yeah, that was a good point. That was in the notes. So that's something you also keep an eye out for. And that dark wedge that'll grow over the rest of this year as the planet moves more and more out of alignment with the sun from us. Talk about the moons for a second. So here we've got Saturn's biggest moon, Titan. It's one of the, I think it's the biggest moon in the solar system. Titan is quite bright. I've got the magnitudes here in a second.
I'm going to look it up real quick because something inside of me is saying that Titan is like the second biggest one, because I remember thinking that it's silly that they called Titan. Hold on.
Yeah, probably Ganymede or Callisto must be number one. And Titan must be number 2 or 3 in the list. And our moon is way down the list, actually.
Ganymede, yeah, you were right. Ganymede is first and Titan is second. And I always thought that was very silly.
So Titan takes about 16 days to orbit Saturn. And that means that if you check Saturn out, you can typically see at least Titan, if not some of the other moons. I'll talk a bit more about that in a moment. And if you watch on a number of different nights, let's go back to tonight here. So tonight, Titan will be kind of to the upper right. And don't forget, your telescope might flip this arrangement around, right? So if you've got a Schmidt-Cassegrain telescope, it'll probably mirror image. And if you have a Dobsonian, also a refractor with a star diagonal will do this. And if you have a Dobsonian reflector, it'll flip it twice. This is the unflipped binoculars sort of view. So Titan will be up in the upper right. And in 16 days, it'll migrate counterclockwise and end up roughly back where it was. That's something you can keep an eye out for if you've got, keep the telescope handy for the next little while. Now, once it gets dark, the darker the sky, the more moons that you're likely to be able to see. So you can see an 8-inch telescope could see 7 moons of Saturn under dark sky if the seeing is good. As I said, Titan. So Titan is magnitude 8.5. So that's certainly binoculars range in most cases. It'll wander about 5 times the ring diameter from the planet. So if you sort of use the ring diameter as a yardstick, it'll wander as much as about 5 of the ring diameters from Saturn. But of course, if it's transitioning, the meridian of the planet, it could be just a little above it. So let's see if I can do this. 18. Yeah. So there's tomorrow night, following night, a few nights hence, and when it heads back, it'll be a little bit below. So it can be closer than that, but that's generally the rule of thumb. The next one is Rhea. So where's Rhea? Here's Rhea. So Rhea's magnitude 9.9. It stays within 2 ring diameters or ring widths of the planet because it's got an inner orbit. Then we got Dione and Tethys. So here's Dione, here's Tethys. They're about the same magnitude. They're about 10.5, magnitude 10.5. And they'll always be within about 1 ring diameter of the moon, of the planet. Then we've got Yapitus. Where's Yapitus? Yapitus can be...
how you pronounce that.
There it is, Yapitus. So Yapitus can wander up to 12 ring diameters from the planet. It's got a large orbit. Yapitus is cool because a Yapitus has a dark hemisphere and a bright hemisphere. And that the moon is tidally locked with the same face towards Saturn. So as it orbits Saturn, we in turn see its bright hemisphere and its dark hemisphere. So when it's on the I think it's on the west side, it's brighter, and when it's on the east side, it's dark. So the magnitude number will vary over the course of a number of days as it transitions from one side of the planet to the other side of the planet. So that's something to keep an eye out for. But it's roughly about magnitude 11. So it's certainly within reach of most backyard telescopes. And then we have Enceladus. Do we have Enceladus here? Where is he? Here's Enceladus. So Enceladus is a tiny little moon, but I think it's about 600 kilometers in diameter. It's not a very big moon at all. And it's magnitude 11.9, and it stays very close to the rings. And the other one you can see usually is Mimas. So Mimas is actually just hidden. Let's see if I can bring it out. Where's Mimas? Here we go. There's Mimas. So Enceladus and Mimas, they stay pretty close to the planet. It's about magnitude 13.
We have some moony questions.
Sure.
One from Joanne, which was, are all of Saturn's moons rocky or icy, or are some gassy? And I mean, I would say that all of them are rocky or icy, but Titan's atmosphere is very gassy. Would that be right?
Yeah. So Titan is actually not too dissimilar from Pluto or some of the moons of Jupiter. Basically, the moons of the outer solar system are mixes of ice and rock, combination of ice and rock. Generally, more ice the farther you get from the sun, just because the concentration of the H2O in the solar system's primordial cloud was, increase with your distance from the sun. The star of our sun kind of dissociated the atoms, the molecules of water, and left the colder regions more water rich. So the outer planets have more ice in their moons. I believe Titan is now thought to have a potential of a liquid subsurface ocean or subsurface layer, much the same as Europa would have.
Really?
I know Enceladus has
it has liquid on the surface, right? It has liquid methane on the surface.
Well, so it has, again, if the moon has been differentiated or allowed to be heated by its tidal forces with its host planet, it can actually differentiate over time, which means the heavy material sinks to the core and the lighter material floats to the outer surface. So a moon like Titan is thought to have a concentrated rocky sort of core, and then a more outer shell of kind of potentially liquid water underneath that icy crust. So it's 100% cold there all the time. So everything's stay cold. And then it's got the hydrocarbons are able to be liquid at those temperatures. So they form the so-called water cycle of the planet, right? We've got liquid methane raining down from the atmosphere and then flowing and carving erosion channels in the planet's surface. And it's just fascinating, right? We have pools of liquid hydrocarbons on the surface. We've got a Lake Ontario on Titan. And then the atmosphere itself is very, rich in hydrocarbon gases and that kind of thing. So,
but it's not gassy the way that Jupiter and Saturn are gassy. It's gassy in that it's sort of gassy the way Earth is gassy almost.
Yeah. So it's got the rocky portions are in the middle. The icy portions are on the outer layers. And then the gas, as limited as it is, forms the atmosphere on the planet. And the reason it has an atmosphere is because it's massive enough to hold on to that gas from being blown off by solar winds and other things. So the other smaller moons of the outer planets have either no atmosphere at all or very, very, very tenuous atmospheres, just because they're not massive enough to keep their volatiles. Yeah, cool topic. Moons are a good one. We could do moons one.
Moons are very cool.
So more things to look for when you're looking at Saturn. Saturn has the rings are divided into different named or numbered zones or lettered zones. We have the A ring, the B ring. We have a very faint C ring, which is certainly potentially possible to be observed in a backyard telescope if your sky conditions are excellent, your optics are excellent. But generally, most people see the A and B ring. And if you've got a good enough aperture and good quality optics and good seeing, you can see the The Cassini division is that gap between the two ring sets, between the A ring and the B ring. And the Cassini division is actually helped to be maintained by some of the smaller moons of the planet, which are kind of clearing out or gathering up the material in their orbits. There's also a very thin ring, and if you can see it here, this is called the Encke division. So it is theoretically possible to see the Encke division in an amateur telescope, but again, you need good optics and good conditions to see that. So they say the Cassini division is 5-inch, 6-inch telescope and up, aperture-wise, to get a decent clear view of it. Yeah, we talked about the shadow on the planet. We can look. You can see banding on Saturn. So if the conditions are good, you can look for the planet will look brighter near the rings, near the equator, and it'll get darker as you move into the temperate areas. And then we know that Saturn has polar vortexes and hexagons and cool stuff, but we can't really see those here unless perhaps the planet is fully tilted towards us. So just to finish up, a few more things, a few tips for Saturn. It's going to be best visible right now when it's transiting in the south about midnight, when it's highest in the sky. And that will give you, it's still shining through almost 3 air masses. So the seeing isn't as great as it's going to be in a few years when it gets to be higher in the sky. Let the sky get nice and dark so you can pick up more of the moons. If you've got filters, you could try putting some filters in your telescope. The number 21 orange filter can help bring out the cloud bands on the planet. And the number 56 light green filter can enhance the cloud belts as well a little bit.
Sorry, this is entirely filter related. Are filters numbered standard?
The Ratten system are, yes, WRATTEN, the Ratten numbers. I think most vendors are quoting those numbers. Yeah.
Okay.
But basically the rule of thumb is that an orange filter or a light green filter will help enhance it. So whether or not you have numbers labeled on your filters, those are the ones you can try. And there's no hard rule about it. You can try other filters as well. One of the things I was planning to mention when we talk about Jupiter is that I don't use colored filters in my telescope, but I do have nebula filters in my scope. And so sometimes if Jupiter's there and I'm waiting for it to get dark so I can look at nebulas, I'll just see what does my oxygen 3 filter do, or what does my UHC filter do? And in fact, it enhances the belts and it enhances the red spot. So if you've got a UHC filter or an O3 filter, what's the harm? Pop it on and take a look. All right, let's switch over to Jupiter. So Jupiter, again, chasing Saturn across the sky, much brighter. It's about 17 times brighter than Saturn. So it's easy to tell which one's which, not only by the color, but by the brightness as well. It's going to reach opposition on Thursday. At that time, it'll be, I think, 600 million kilometers. Compare that with Saturn's opposition, which was 1,337 million. So it's half as far away.
Wow.
Now, that's 33.3 light minutes again. So we're seeing everything happening about half an hour in the past. We're looking at Jupiter, and it'll shine at its maximum brightness of the year of about minus 2.88. So obviously you can see Jupiter no problem at night with your unaided eyes. If you've got binoculars, try them out and see if you can see the Galilean moons, the dots along the planet. I can see the moons in my 10 by 42 binoculars. No problem, no question about it. That's fun to do. And obviously telescopes as well. But one of the cool things you can try to do is you could try to see Jupiter in the daytime, not during opposition time though, because during opposition time, Jupiter's only up at night because it rises at sunset. But once we get into November and December, we might be able to try it around, I've got one in the events noted here. I don't know if I put it in the notes here. October 15th. Let's try October 15th. There we go. Here. So on October 15th, the gibbous moon, the waxing gibbous moon, will be located only, I think it's about a binocular's width, 7 degrees to the southeast of Jupiter. So, obviously taking care with the sun, as always, whenever you're using optics outside in the daytime. But you can try to see by using the moon as your guide, whether you can see Jupiter in your binoculars first, and try when it's still light out. So this is still dusk, but see if you can see it in the daytime in the binoculars, and then pull them down, see if you can see it with your eyes. And I've done it. It works, no problem. It's very easy to see it once you know where to look.
It is amazing that when using, especially using binoculars, excuse me, or a telescope to help you find it the first time, it's amazing what you can see once you know something is there.
Yeah, absolutely. All right, let's go back to Jupiter tonight. Here we go. Okay. Again, you don't need to overly magnify Jupiter. Just get it to a nice, comfortable size. Stop magnifying it when you start seeing the belts look crisp. So, you can stick with 30x or 50x, 60x. If your seeing conditions are great, you could try to go beyond, but don't be surprised if you want to dial it back. Let's see, what else can we talk about? So you want to look for the stripes on the planet. So the stripes on the planet are actually, you're looking at the weather on Jupiter. You're seeing the dark zone, the dark belts. So there's an equatorial belt and there are temperate belts. And those you're seeing deeper into Jupiter's atmosphere. And then the whiter zones, these are shallower, so these are higher altitude levels as well. And the color differences are due to basically chemistry. The chemistry of the atmosphere is different at different levels.
And that was,
you can look, go ahead.
I was just going to say that came up on Reddit actually a couple of days ago. Someone asked why Neptune, which is more or less the same composition as Jupiter, was blue instead of red. And I'm sure there was a really great answer. I don't remember it, but it was essentially, it boiled down to like it's not the hydrogen and the stuff that makes up most of the atmosphere. It's like the 1 to 2% particles that cause things like the color to change. When I say 1 to 2%.
Yeah, I don't know what how delicate the balance needs to be, but certainly you could find a graph, of the relative compositions of the common volatile gases in the solar system. You'd find that, Jupiter is really dominantly hydrogen, helium. I think Saturn is as well. And you start getting into ammonia and more of the other ones when you get into the ice giants. We actually do, planetary scientists actually distinguish Jupiter and Saturn as gas giants versus Uranus and Neptune as ice giants because of that compositional difference. Mm-hmm. And when they say ices, they're meaning more of ammonia ices and other types of things, the sort of things that we saw when we flew by Pluto, those colored zones and things like that. You can also, when you're looking at the planet, if you've got good optics, good seeing, you can look for these festoons, these sort of little streams of dark bluish within the white zones. You can look for darker spots. They're sometimes called barges, concentrated darker areas within the belts. And you can also look for, sometimes there are little white ovals. And these come and go over time. So this stellarium image of Jupiter was taken at some point. I don't know when. It's not how Jupiter looks currently, right? But if you go into the Juno mission, you can certainly get current what it looks like. And we can also dip into our friends, the planetary imagers, as I'll do here in a second, and see what it's looking like currently. Because Jupiter is a big ball of gas, the atmosphere, the equatorial part, rotates once fully in about 9 hours and 50 minutes, so almost 10 hours. And the poles are a little bit slower. It takes about 5 minutes extra time for the poles to catch up and finish their trip around the planet. So that differential rotation gives rise to some of these, different speeds at different latitudes. And so you get these complex weather systems forming aside from the Great Red Spot. You can also look around when you're looking at Jupiter. Notice to see if you can tell that the edge of the planet is noticeably darker than the center of the planet, and that's a phenomenon called limb darkening. And that's because there's kind of a hazy outer atmosphere on Jupiter that's actually absorbing the sunlight, and it makes the edge of the planet a little bit darker. And that actually has an impact on the Great Red Spot. So the Great Red Spot, let me just bring this back an hour or two here. You can see there's the Great Red Spot. So the Great Red Spot is a cyclonic storm. It was there when Galileo first looked at Jupiter. It's been there when Cassini looked at Jupiter. It's been there, as far as we know, all along for hundreds of years. I'm not currently up on the latest as to all the theories, but it's really a fascinating object, right? It does vary over time. So currently, it's gotten a little smaller and a little fainter or paler than it traditionally was. And what I'm going to do is I'm going to show you a picture. Let me just open this hyperlink up and bring this picture in. This is so Damien Peach and Christopher Go are two amazing astro imagers. We also have some in RASC as well, but these two gentlemen are located on the Earth where the planets are higher in the sky, so they get an advantage of getting clearer views of them. So Damien Peach just a few days ago posted this comparison of the Great Red Spot now versus back in 1981.
1891? Was there?
Yeah.
Sorry, 1891.
1891, sorry. 1891.
Oh my goodness.
Yeah. So showing how it's it was more elongated at that time. And there's the Earth to scale, so you get a sense of how big the spot is. It's 1.5 or so Earths in diameter. And so this is actually a current picture, right? This is just from last week, and you're seeing the how pale the spot is. You're seeing some of these dark barges and spots and things like that, and some festoons coming through. So yeah, pretty cool. I'll put that away.
We have a question not about the Great Red Spot, but instead about diamonds. So I know that doesn't sound relevant, but it is. There's a question from Cicely, which was, this is more specific to Neptune, I think, because Cicely asked, is it Neptune or Uranus where it rains diamonds, which is something that a lot of journalists often grab onto. And from a quick search online, it does look like the chemistry is appropriate on Neptune at the very least, possibly Uranus as well. For diamond rain, there was, and it looks like there's actually an article from 2013 in Science Alert. Sorry, that's not true. On the BBC, saying that it was possible that diamond rain could also fall on Saturn and Jupiter, which they had not thought it would. But in 2013, this evidence was suggesting it. I don't think that evidence has held up. Well, Chris, do you have any ideas?
I can't claim to be a complete expert on it, but you have to think about it this way. A planet like Jupiter, Saturn, Uranus, Neptune, they have different regimes, physical environments on the planet. So at the very outer edges of the planet, you've got very low atmospheric pressure. And then as you dive deeper into the clouds, eventually you get the point where not only is the hydrogen squeezed to the point where it's solid, but go beyond that, and they say that the hydrogen is potentially even metallic in the interior of the planet. So there's a continuous increase of pressure as you dive deeper and head towards the core of the planet. And you probably don't have to get very far into it before you're at the point where you're going to be condensing different chemical elements, different molecules that are in the atmosphere. And so that would be the point where you're transitioning from gaseous to solid. Basically, you're freezing out the chemicals that it could potentially solidify and maybe it rains. Maybe it's flakes, maybe it's dust. I mean, to say rain, it means that something's got to be concentrated enough that it can clump up and form a drop and come down. So who knows? I don't know. It's fun.
Yeah, it's an interesting thought. I've sent the link to the Science Alert article about Neptune and the rains. And it mentions Uranus as well. From what I saw online, there was also like a diagram that kind of showed that it's possible at the sort of towards the core of the planets that there's like a molten carbon soup, which would be the carbon diamond rain landing in this like giant molten. It's a lot more apocalyptic than I think the headlines make it sound. Like if you were there, it would be terrible. It's not somewhere you just like scoop up and you're like, oh, look at all these diamonds I got. It's like you're definitely 100%
no.
Yeah.
No. And the chemistry is so complex that, I mean, they're just focusing on the carbon aspect, but there's all kinds of other phenomenon that could be happening at the same time. I'm sure it's really cool, but what we need to do obviously is send a spacecraft, voyaging into the interior of the planet as far as it can reach and record some of these things. So, yeah.
Something to think about, though. Thank you for the question.
Uranus and Neptune have gotten very short shrift in our human exploration of these solar systems. So there is really a strong push to go back there. And of course, it's crazy because now we want to go back to Pluto. It was so interesting. And, we're finding so much cool stuff about Saturn. Carolyn Porco, we were at Cassini. Cassini was there for so long. I learned so much, but still there's more to know. So, we have to, everybody gets to compete for what to do next. Mm-hmm. But the exciting one is the potential of a helicopter drone that's going to land on Titan and fly around.
Yes.
That's the Dragonfly.
That's going to be the really cool part because the surface of Titan is something really interesting.
Okay, let's get a little deeper. So we've got the Great Red Spot appearing on Jupiter because Jupiter rotates about once every 10 hours and the Earth rotates once every 24 hours. You can see that they're out of sync. So that means that if you want to see the Great Red Spot, it's going to be in your evening sky, let's say, about every second or third night. So when the Earth goes around twice plus an hour, then Jupiter's gone around exactly 5 times. So that's sort of how you can sort of think of it. Remember that everybody on the Earth sees Jupiter the same way, as long as it's above the horizon where they are, right? For some of them, those people, it'll be daytime, and for some, it'll be nighttime. But basically, if Jupiter's Great Red Spot is crossing the middle of the planet, then everybody on Earth who sees Jupiter in a dark sky will see that same event. What else? So I showed you the Damien Peach. There are tools that you can use to decide when the spot is visible. If you have an old version of Stellarium, it's probably wrong. So the feature was built into Stellarium some time ago, but it hadn't been debugged and perfected until the latest version. So I'm using version 21.1, I believe. And we worked out, I work with Blake a lot on this, and we worked out, whoops, that's not what I want, that in this version of Stellarium, it's now fixed. So if you've got 21.1 loaded installed, then whatever you're seeing, whenever you see the spot on Jupiter, you can count on that's what you'll see in your telescope. Otherwise, you can use other tools. So there's a tool that Sky and Telescope puts out. I'll just open up that hyperlink and show you, and you can put it in the link if you want to. Yeah. So here you can set to just click initialize to today and say today. And this will tell you that on August 17th at 0355 Universal Time, that's when the spot should be centered on the planet. Now you're going to have to adjust from Universal Time to local time, or you can use the local times listed on the right-hand side. So this is telling me that for the GTA, that the Great Red Spot should be centered on the planet Well, that's 9:50 a.m. That's not helping me, but basically on the 16th at 11:55, or I could even set, I'll go into the future a little bit. Let me just go ahead another day. So 1:30 a.m. on the 19th. Let's try that. 1:30 a.m. on the 19th. So I'll go 1:30. And you can see it. I don't have it quite perfect, but so that tool will let you predict when the great red spot is visible where you are. So you can use that one. Go ahead.
A couple quick stellarium related questions. Does the version number that you're using, that 21.1, does that apply to Max as well? Do you know?
I'm not sure what version for Mac it's up to, but essentially if you go and get it now and install it, then you should be fine.
Okay, and I think you can also delete your version and install a new one, and it'll solve the problem too.
Normally for Stellarium, you don't need to worry about uninstalling the old one. It'll just overwrite. It'll just write over the new or the current one and update it.
And I've sent this out in the answered questions, but you can download or update the new one at stellarium.org, which the link is now in the chat as well.
I should say that the Sky Safari app for smartphones, it maintains a correct red spot. Quite a few apps don't worry about the red spot as much. So what you could do is you take your app out, compare it with Sky and Telescope, which is a reliable source, and see whether your app is correct or not. If you have an older Stellarium and you don't want to update it, you can do this manually. So you can go to Sky and Viewing Options, which is F4. Then you can tab over to Solar System Objects. Then you can go down to where it says use the custom settings of the great red spot. You can enable that, go into the details, and you can put the number in here that makes your Stellarium correct for Sky and Telescope, right? So if Sky and Telescope says it's on tomorrow night at 1:33, set Stellarium to tomorrow night at 1:33 and just fiddle with the number here until you get it to be in the middle of the planet. And that'll remember that for a while.
And if you need to go back and remember how to do that, this video is on YouTube.
Yeah.
And you can rewatch it.
Yeah. So some people, they don't feel that they want to update their software. So that's another way around it. That's the way I used to do it up until this version got fixed. Let's see. So what can you use to make Jupiter look better filter-wise? That light green filter number 56 can enhance the bands and the spot. The green filter number 58 can darken them even more, the bands in the spot. The number 80A light blue filter can enhance some belt details and bring out the white ovals a little bit better. And also the 82A very light blue will do the same with a lighter touch. Let's see.
I don't think we've talked about the moons that much, have we?
I'm coming to that.
Okay.
That's the grand finale, is the moons. Yeah.
All right.
As I said, if you have a nebula filter, try that on Jupiter. You'd be surprised at what it will do, how it might work. And the other number one tip for looking at Jupiter in your telescope is to pull out your moon filter and dim Jupiter down a little bit. Most of the time, Jupiter looks too bright in your telescope to really get the full appreciation for the details on the planet. So you can either use a moon filter, neutral density filter to dial its brightness down a little bit, or use the stop down your aperture using one of those sub eye caps to darken the planet a little bit, get more details.
Hold on. As the amateur in the room, what was it called? Sub eye caps? Are those caps that have like the little circle inside?
Yeah, the smaller opening you can use.
Okay, thank you.
Try it. I typically find that helps. All right, so let's talk about the moons a little bit more. So the moons do all kinds of cool things, and that was one of the other reasons we wanted to do this today, is to demonstrate some of the neat things that the moons of Jupiter do. So the moons themselves can look different if you pay attention for them. So obviously everybody notices the pattern that they make, but if you actually look at them closely, you can notice a few things. So the moon, the innermost of the 4 Galilean moons is Io. So Io is smaller and brighter. It's often as if you can get a situation where the Io is about to cross the planet, as it gets onto the limb of the planet or it's exiting the other limb, it's actually brighter than the planet because of that limb darkening of Jupiter. So you'll see it as a bright dot, and then it'll approach, and then it'll be a little bit brighter than Jupiter, and then you'll probably lose it once it gets into the middle of the planet. Io crosses the planet about, well, it has a 42-hour orbit, so it's about every other day. It's getting close to crossing the planet. Europa, which you're seeing here, there's Europa. So Europa is even smaller. It's a small-sized moon. It's whiter and brighter than Io is. So it's not usually, the moon itself is usually not visible on the planet, although its shadow will be, and we'll talk about that in a second. Unless you get Europa crossing one of the dark belts, and then you can see it in the contrast with the dark belt. The moon Ganymede, which is the next one out, it's a rather big moon. Not sure where they all are here at the moment, but I'll just come back a little bit here. There's Ganymede. So let me put this aside for a second. So you can see Ganymede is here, is a big moon. Ganymede is darker in color itself, and so it tends to be darker than the limb of the planet and brighter than the belts. So if it's crossing the dark belts, you might see a brighter moon as it's crossing the belts. It doesn't orbit as often. It's a more a larger orbit, so it takes longer to orbit the planet, and it crosses less frequently. And then finally, Callisto. Callisto is a large moon. It's pretty dark in color, and it's relatively easy to watch as it passes the planet. But it only crosses about every 17 days because of its large orbit. And there are lots of years in Jupiter's orbit where the geometry causes Callisto to miss the planet above or below. So we're not getting it. Right now we are. So we're actually in 2021, we're in a period of time where the Earth is crossing the ring, the plane of the orbits of Jupiter's satellites. And so we're actually getting a lot more transits and mutual events of the moons. So let's talk about some of these moon shadow events. So when the moon crosses the planet, it'll actually cast its round shadow on the planet. And the shadows are pretty easy to see even in a smaller telescope. So you don't need a giant telescope to see the shadow transits. Often they go one at a time. Sometimes there are 2 at once. And very rarely you get 3 at a time. And I'll show you a 3 at a time here in a minute. The sizes of the shadows vary. Let me just bring up a shadow transit here. I have one. I think this is one. No. I'll bring one up in a second here. Just pull this so it doesn't disappear on me. Yeah. So we got, let's see, in order of descending size, the shadows get smaller with the moon. So Ganymede's shadow is bigger, Io, Europa, and then Callisto. Callisto's shadow is the least sharp because it's farther from the planet. And then Io, its shadow is sharper because it's closest to the planet. The time it takes for the moon to cross varies with the moon because of its orbital distance from the planet, but it's roughly about 2.5 hours. Now, I wanted to talk about the current situation. Right now we're at opposition. So let me just bring up Jupiter tonight, and we'll go to the next. I think we said it was 0, and the next one. Let's see if we can bring this up. So here we've got a situation where we're seeing the shadow of Europa crossing with the planet. When the planet is before opposition, then it's east of the sun, so that the shadows are cast on the other side. So I've got here, before opposition, the shadows cross the planet before their moons do. Right at opposition, the shadows sit kind of underneath the moons. And then in the weeks and months after opposition, the moons start to precede the shadows across because it's all the angle which way the sun is coming from. So right now we're getting the situation where the moons and shadows are crossing kind of together. So let me show you just a couple of days ago, we had a triple shadow event. Let us bring this one up here. Okay. So I just put this out of the way a minute here. Well, this was not visible from Canada. It was visible from Asia, Japan, and things like that. So this is kind of a cheat triple. So about 10:30 in the evening in Japan, you can see that Callisto shadow was finishing a transit. And then if you waited a little bit, then you saw Ganymede shadow joining it. So they were both on the planet together for about 12 minutes or so. And then if you wait a little bit longer, so about 11:20, we get Europa shadow joining. So now we lost one and gained one. So now we've got two at once. And then they cross together for a couple of hours.
Cool.
And I'll show you, Christopher Go took a picture.
Yay.
Bring that up.
Christopher Go is in the Philippines, right?
Yeah, he's in the Philippines.
He's an amazing outreach / astrophotographer.
He made a movie. Here's the movie.
Oh, wow. Oh, wow.
So a couple of things to notice, that because the one moon is orbiting closer into Jupiter than the other, the shadows can overtake. See how it overtakes it and passes it?
Yeah. So then, oh yeah, and you can actually even see, the shadow on the moon that's passing in between, what is it, Ganymede, whatever moon is smaller in those two. Do you
Yeah,
see
the
that?
one moon will be covering the other moon. So in this case, let me see if I can pause it.
Yeah.
So one moon is covering the other moon temporarily. Yeah.
Oh, that's so cool.
Yeah. So just go to Christopher Go on Facebook, and he posts his cool pictures there all the time. So you can see that happen. So that's basically a real life photographed version of what I'm simulating in Stellarium here.
Cool.
So very, very cool. Very, very cool. All right. So let's wrap up here. The next true triple event I've got as March 20th, 2032. So let's go 2032, March 20th. Well, I've got to go back home first. Let me do that.
I was going to plug our handbook, but I seem to have misplaced mine. Pretend I'm holding the Observer's Handbook. It's a great resource when you're doing this kind of stuff. And it has all the double and triple transits listed in it of the shadow transits on Jupiter of their moons. So
yeah, the page ones. Let me just cover this up here.
Oh, here, stop. There.
Must have, there we go. So here we go, March 20th of the year 2032. And you've got 3 moon shadows and the Great Red Spot.
Wow.
All traversing together.
Like at the very same time. They're all
And you can
lined
see
up.
that the rate that they travel the disk varies with the moon. So Io's shadow moves faster. And then you've got Ganymedes and Callistos more northerly.
And Ganymede, I think Ganymede's the slightly largest one.
Yes.
So Ganymede looks like it's moving at almost the same speed as Jupiter is rotating.
Yeah, it's all the geometry of the situation. So
Cool.
yeah, it's very,
I'm just
very
thinking
cool.
of it from the perspective of like, if you were on the surface of Jupiter, you would be in shadow for a very long time as Ganymede was blocking the sun for a while.
Yeah. I mean, if you were living on Jupiter, you'd be seeing solar eclipses.
Yeah.
Right? That's what those are. Yeah, so I mentioned there's a Europa Shadow coming up August 19th at 12:30 a.m. from Canada, and Io Shadow will be Thursday night. So I can show those here. Let's see. August 19th. I think it's this one. So you've got Europa Shadow just starting. And yeah. So anyway, you can, I'll give you some tips to find when those are happening in a bit here. So the other thing that we get happening is that we get mutual moon events where one moon can not only cross its shadow across Jupiter, but one moon can eclipse or block another moon from view. So an eclipse is defined to be when one object blocks the light from landing on the other moon. So that would be a total lunar eclipse for our Earth moon system. An occultation is when one object covers another object. So that's a total solar eclipse is actually not an eclipse, it's an occultation. And a transit is when the blocking body is not big enough to cover it. So it just transits the other one. So the transit could include transit of Mercury, transit of Venus, International Space Station flying across the sun or the moon, or an exoplanet traversing a star, right? Those are all transits. So Venus is going to transit Jupiter. Just random extra bonus for you. November 22nd, 2065. I don't think I put that one in here.
Sorry, what was happening?
November 22nd of 2065, Venus will transit Jupiter.
That's Jupiter. Cool.
Yeah.
I believe next year, I don't know if they're transiting or if they're actually, it would be eclipsing or if it's just a really close pass, but Venus and Neptune are at like 0.01 degrees apart or something like that.
Yeah, every now and again we get, oftentimes they're not visible from where we are, but occasionally we get lucky. So this is an article from a recent Sky and Telescope article. You can put the link in the chat, and it's basically talking about how the different moons can interact with one another. So you can have one moon passing in front of another moon. You can have one moon blocking the light from a moon beyond it and creating a little eclipse situation. Here's another example. So here's a little graphic showing the different situations or scenarios. And here's a little GIF. So watch how, see the shadow runs across? Quite amazing. Quite amazing. So you can look at that one at your leisure. I think I listed one here. So this one is happening in Canada, and I think I advance the time here. Do this right. I think Ganymede will block the light.
Oh, that's cool.
Or maybe I got it wrong. Let me try that one again. Maybe I ran it backwards.
Looks like
anyway, what I'll do is I'll show you how you can find these. I think maybe this one will work better. Let's try this one. So here's another scenario that you can look for too, is Jupiter itself casts a big shadow, and sometimes you can lose the moons in Jupiter's shadow. So here's one where Ganymede disappears before the planet covers it because it's gone. Jupiter's blocking the light from reaching Ganymede.
Cool.
Those at opposition, those happen very near the planet, but in the months before and after, those events happen while the moon is farther away from the planet. So this is a little tricky, but I'll show you how you can, for those who are interested in a bit of a challenge, let me just open up this website that you can go to. So this is a website that lists all of these events. It's the ephemerides for all the mutual eclipses and occultations of the Galilean satellites. And what you need to do is tell it where you're looking from. And in this case, there's a list here you can click and open and run through the list and find your nearest city or town. I happen to know that Toronto is 770. And if I click show, then it'll give me for the Toronto area, the year, the month, the date, and also then it'll give me the time, the type. So this is moon 1 eclipses moon 2. So 1E2 is moon 1 eclipses moon 2. or moon 3 occults moon 2, that kind of thing. And so the one that I counted out here is August 9th. We had Ganymede eclipsing Europa. So let me just bring that one up here. I'll just run this back to on the 9th at 11:38. Okay, and we need see, it should be Ganymede eclipses Europa, August 9th at 11:38. Sometimes these don't work. Yeah, I have to play around a little bit with it. I'm not gonna bother debugging it right now, but
it might be. Yeah.
So let's see. Last thing, I think. Oh, one other thing you can use is now the latest version of Stellarium has added a tool for calculating some of these events. And if you go to the astronomical calculations window F10, click over to phenomena, you can choose Jupiter, and you can choose the moons of Jupiter. You can put the date range in. So August 17th, it does a month. I'm just going to put this back to August, say 19th. Calculate the phenomenon. And after a few moments, it'll pop up a list. And then if you look at the list, so I just usually sort this so that don't worry about Adastra, Amalthea, Metis, Thebe. Those are minor moons that you can't really see with a backyard telescope anyway. But if you focus on Europa, Ganymede, Io, and Callisto, then you can look for the list. So you can say, Europa occultation at this time, and you can take any of these, you can double click them and it'll jump there for you. I'm having trouble getting this to work properly. I have a funny feeling there might be a little bug with it, but definitely the shadow transits work. So you want to know when Europa is crossing Jupiter, you just double click and it gives you the center of the event, center time.
Cool.
So you can do that. And that's working. That's already in Stellarium. And last thing I wanted to show was this last tool. And this I found pretty easy to use. It's another one of these. So this tool, shallowsky.com/Galilean, shows you the current, here's the date and time here, the current arrangement of Jupiter and its moons. And you can ask it to show you the events for whatever. It's got 8 hours. You can put in 24 hours, say predict, and this will tell you that Io shadow will appear on Jupiter at this time. And these are local times. So if you see something, these are all 3 in the morning, 5 in the morning. If I go, say, to 48 hours, you get a few more. So you can look it up here, and then you can dial in those dates and times in your Stellarium, and you'll see these events happening. So that's a cool little tool. All right. So I think the only other thing I was going to talk about was a little bit about Uranus and Neptune.
We do have at least one quick question and one possibly longer question regarding Jupiter in particular here. If moons of Jupiter only take hours to orbit it, which is 11 times the size of Earth, do you have any idea of the relative speed of Jupiter's moons compared to Earth's moon? Because Earth's moon is looking real slow right now.
Off the top of my head, I don't, but you could certainly Google the speeds, and you can calculate using, by assuming they're a circle and calculating the radius of the orbit, how long it takes. Right. So the Earth is, what is Earth's moon? 300 and something thousand kilometers in roughly 30 days. So you can work out the speed it's moving, and you could do the same math with any of the moons of Jupiter as well.
Maybe we'll try to do the math sometime.
Yeah, we'll do a moon special sometime. Yeah.
And then another quick question from Ed, which is, Stellarium has been free forever. Do you know who's behind it? Because it is awfully generous that we have been able to use it for free forever, and it's used by so many people. Is it open source?
It's open source, but it is driven by a few people who are the originators. And you really make a good point. I think down here, there is, here's the following people and organizations behind it. So sponsors, community developers.
Wow.
For many, many years, a number of us that do outreach were using a website called calsky.com. It was amazing, and it had planets and Great Red Spot and phenomenon of different moons and planets and things like that. And the fellow that, I'm assuming it's a fellow, could have been a woman as well, but whoever was operating it shut it down because they didn't have the funds to continue it. Oh. And I'm sure a number of us maybe weren't paying attention and could have chipped in some funds to support. So by all means, if you want to donate a little bit of money to Stellarium to help keep it going and keep it alive, I think that's a great idea. Mm-hmm. So if you go to their website, I'm sure you'll be able to find a spot where.
There it is, donate to our collective at the bottom.
Yeah, you can actually, yeah, there you go. You can help them out. Mm-hmm. So that's a great idea. Thank you for mentioning that. Questions?
That is, oh, wait, hold on. Nope, that's everything. We've caught up on questions. I have to leave ever so slightly early today.
Yeah,
so
let me just rapidly conclude by mentioning that if you're interested in Neptune and Uranus, Neptune is sitting here about, I think it's about 20 degrees east of Jupiter, so it's following across the sky. Everything rises about 4 minutes earlier every night. So every week that goes by, it rises about half an hour earlier. So right now, Neptune is rising a little after 9 p.m. and Uranus is lagging behind a couple of hours. So by the time we get into October timeframe, there'll be nice evening targets. You'll be able to look at them. Yeah, and we can talk more about them as we get into the future sessions. So I'll stop sharing.
There's some really cool stuff with Uranus and Neptune. And I know that our executive director loves them out there. So we have to cover them sometime in more depth. Thank you all so much for joining. I'm so sorry for the confusion about the login and transferring over into this new sign up for this new event. But we will be going with this event indefinitely. And so if you've signed up, you are good to go for our next sessions. Next time, we're going to be talking about our favorite space and astronomy books. And we should be joined by quite a few outside folks because we'll be inviting some libraries to join us. If you know of any libraries that would like to join, we are offering a partnership with them for sharing outreach numbers. So please get in touch with me. I'm happy to talk to them if you think they might be interested. Thank you all so much for joining. It was lovely to see you all again. Our next session will be in a month. It won't be August, whatever is 2 weeks from now. Wait, hold on. Yes, it will be September 14th.
I don't remember, but yeah.
Somewhere close to that.
And then we'll resume our bi-weekly again.
Yeah.
Yep. Thanks, everybody. So yeah, by all means, also send us your suggestions and otherwise keep looking up.
Yeah, we'll see y'all in a month.